All right, let's introduce the t distribution. So up until now, we've been using the normal distribution. And when it comes to means, which is what we're going to be looking at next, we're going to use a different model called the t distribution. So before we get into it, just a little information about who developed it, known to be discovered by William Seeley Gossett. Um, and he was a statistician employed by the Guinness Brewing Company. It is also given the student's model because he went by the pseudonym student because he was not allowed to publish under his real name. So if you hear student model, you know we are talking about a T model. So let's go ahead and look at the characteristics of a T model. It's actually very similar to a normal model. If you look at it, what's in black over here, that is our standard normal model. And when you look at the t distribution, it has to do with degrees of freedom. So the larger the degrees of freedom, so in other words, when your degrees of freedom, when your sample size goes to infinity, what happens is that your t distribution will start to resemble a normal model. So if we look at the red one, the red curve right here, you could see that it has a degree of freedom of 8. And if you look at the tails on the ends here, the tails are a lot fatter than the tails of a normal curve. So right here, this is the tail. And so we have a lot bigger area under the tail when we're looking at a T model. So the larger though your sample size, you are going to approach a standard normal curve. So let's look at the characteristics. So the T curve is a bell shaped as well and also has a center at 0. So instead of a Z score, we're going to call it a T score. So we're going to be looking at T scores, and the way we get T scores is just like the way we get with Z scores, but T scores have to do with degrees of freedom. If you're looking at the green one, it gets a little taller and the tail gets a little thinner. So basically, one way I like to remember this is short and fat. So the shorter it is, the fatter the tails. In other words, the smaller the sample size, the shorter the curve will be and the fatter the tails will be.